Hello, my name is Jim Robb, and I'm the president of the National Training and Simulation Association. So welcome to our June webinar, excuse me, with the theme Complex Multi-Domain Operations in support of the warfighter through application of the M&S. For those new to NTSA, we are a nonprofit association dedicated to facilitating dialogue between government, industry, academia, on topics related to providing the best training and training systems for our warfighters and first responders. We host a portfolio of 9 events each year, the last of which is IITSEC, the largest training and simulation conference and exposition of its kind in the world. We created the webinar program in response to COVID, but the reaction to it has been so strong that we decided to continue it for at least another year. The format for today's event will be an introduction of our moderator, and following that, a panel will have opening remarks. We will answer questions you provided in advance and attempt to address those you send through the system during the event. So thanks for your questions in advance. They were really good. Due to limitations, we're gonna, of the panel's time, we're gonna limit to 1 hour, so that we promise you that. So let me now introduce our moderator, Colonel Chad Bates. Colonel Bates is currently the Special Assistant to the Commanding General, U.S. Army Cyber Command. He's focusing on readiness and modeling and simulation analysis of the Army's cyber, electronic warfare, network, and information advantage workforce. He joined the ranks of the FA-57, a simulation operations officer, in 2005, and focused on the field of modeling and simulation and data science. He holds a PhD from George Mason, specializes in Earth system geospatial information science with a focus on spatial analysis and work process improvements. So that hurts my head just thinking about it. So Colonel Bates, let me turn it over to you.
Sure, thank you very much for that. So good day, everybody. And I have a really good panel for us to discuss the topics that complex domain, multi-domain operational training. So on the panel today, I got Dr. Catherine Morse. She's had a very extensive field in working in modeling and simulation for over 40 years. 25 of that is really looking at standardizations and interoperability type of events. And she's going to be talking about our cyber data exchange model and the work that we've done on that one, really laying that foundation of, okay, so if we're going to have interoperability, what are that common lexicon and information sharing we need to do? Next, I'm going to hand it off to Mr. Alan Geddes. He is a training expert and the Science and Technology Manager down at the U.S. Army Combat Capabilities Development Command, working within the Soldier Center or Simulation and Training Technology Center, which is a mouthful. I understand that, but he is the technical lead on CYBERSPACE Warfare for Training research program. So he's going to have a great presentation of the work that they're doing right now. And then I'm going to finish up with Mr. Clark Heidelbaugh, who works cyberspace and electronic warfare modeling and simulation for Tritium. And he's working on a project with us on a modeling and simulation framework for cyber electromagnetic operations. And he's going to provide that, but he has an extensive background of himself too. And this is going to be really whetting your appetite for a lot of this information, since we only have an hour, we don't have a lot of time to really go in depth. So graciously, NTSA is establishing a cyber pavilion at ITIC that Admiral Robb was talking about, where we're going to go into much more detail. Not only what's available out there, but requirements, capabilities, and challenges that the joint force is having, and probably even some government individuals. So if you want to know a lot more about what we're talking about and get more in depth in a larger portfolio, really you need to go out to see that cyber pavilion we're going to have at ITSEC this year. So I'm going to set the stage. If you go to the next slides, please. So I'm going to set the stage exactly moving forward of well, what is the problem set we're talking about here to help explain what we're talking about? So next slide, please. So this is really the complexity. When we start talking about multi-domain operations or joint all-domain operations and command and control in that battlefield, if you really look on that left side, it is the operating environment that we have for today and into the future. As you can see, what conflicts are going around the globe now, what's happening and everything else. So it's everything from electronic warfare, cyberspace operations, the intelligence collection facilities, but also all that information operations, that PSYOPs, misinformation, disinformation, it gets all combined together. Because at the end of the day, any kind of military force, we want to affect the behaviors of our adversaries to do what we want them to do. So how do we do that? And we have now this growing portfolio of capabilities to influence and change those behaviors as we go forward. Why at the same time, like on the right side of the screen, those entities on the battlefield, those individuals is gaining much more complexity. Everybody has cyber personas. Everybody has different kind of cell phones or anything or different kind of things, even from Fitbits that emit something into the electromagnetic spectrum. So that's this complexity. But then at the base of that, if you're going to affect behavior, you really have to look at what those are, what makes us human. And those, what are our loyalties? What is our thinking? Everything like that, because all that has to be put together and understood when you really have to do it. And I want to talk about for simulations, how do we simulate that? Stimulate the systems, or how do we simulate that kind of environment so we can understand it? Because this is an extremely complex cognitive environment. And the only way we're going to get it right is if we have multiple variations and multiple iterations that we can go through to provide that kind of a cognitive model for commanders, staffs, and other organizations to kind of understand what we have to go through, because we're not going to be able to predict the future. So can we provide enough variability so we can have a better understanding of it? Next slide, please. So as I said, very complex. So the way I've been boiling this down on the left-hand side, there's cyber for cyber, or CIMA for CIMA, which is really talking about those high fidelities. When I talk about cyber for cyber, I'm talking about those really high fidelity type of environments where we have, very individuals in the cyber mission force looking through exactly what routers, networks, firewalls that they have to penetrate. So that's a very high fidelity environment. But the bigger environment on the right-hand side, the cyber for others, or CIMA for others, is at the end of the day, in this complex environment, a lot of the stuff when you're talking about the electromagnetic spectrum is human created, and we have to have technology to understand that environment. So utilizing that technology and understand that environment, that is where individuals, commanders or staffs or other organizations are going to understand and also can be manipulated. So at the end of the day, as a home station training is, and I use this a lot, is if I have a network and I'm either being jammed and I'm jamming that network by 20%, what does that look like at the end state? If somebody's looking at something with their mission command information systems in their operations center, what does that look like on their system? And then they have to understand, it's like, okay, is this, I'm under a cyber attack? Am I being jammed? Or is this the network down? So what are those processes and procedures you have to go through to understand of what exactly the problem is? And then the follow on is the true training environment is, okay, what do I have to do to mitigate it? So I can move forward. And at the end of the day, I think Nirvana is, cyber for all is how do we, those two, cyber for cyber and cyber for others, or CIMA for CIMA or CIMA for others, and combine them to actually, as they have a relevant training environment or an exercise environment moving forward. Next slide. So one of the ways we've been getting after this, using the Army Modeling and Simulation Office that they've put together, is since 2016, we've been having a Army Cyber EW Modeling Simulation Working Group that we've been getting together. And this is a coalition of the willing. And we're up now, starting out with like 12 organizations, we're now up to 50 organizations that are laid out in that little bubble chart that's presented before you. And there's other work groups that are going. There's a network modeling station and fires and other kind of topics and intelligence that are trying to look at from their subject matter expertise, their lens of like what is out there in the modeling and simulation. But what this really is an environment where people like, I am building this, or I am investing my resources in this kind of capability. Is there options or ways we can build once and use many times? So that is what we've been doing here, is taking models that different organizations have built or simulations they have built and trying to bring them into a larger organization. And also the portfolio that the Army and the DoD has and their force-on-force simulations, and how do we take these into each specifics and bring them into this larger simulation? Because that's at the end of the day, all those simulations is at each one of the installations and what's utilized in different exercises. So how can we enhance those basic simulations with some kind of capability moving forward? Because at the end of the day, we're talking about multi-domain operations and all its complexity. There's no overarching organization that is like, oh, okay, I'm looking at cyber, I'm looking at electronic warfare networks and everything, and bringing it together and have a complete understanding of an architecture that looks for it. Maybe that will be in the future with the synthetic training environment within the Army, or maybe there's and I know the joint domain, joint staff is working at different options. But right now, at the end of the day, for us and for Army Cyber, is how do we do home station training? What can we utilize now that we actually have on the books and get those resources to the people that need them so they can start doing those cognitive exercises and start understanding this complex battlefield in the future. Next slide. So this is the gaps that we've been working on. And these using micro investments we get from the Army Modeling and Simulation Office and from organizations, we've been slowly working at these overall gaps that we have identified. And this has been refined since 2016. So it's just an iterative part. And this is talking to the community of those 50 organizations, of asking them, in your viewpoint, what are the gaps? This is not one organization identifying it. This is really this coalition of the willing and these subject matter experts that get together and say, oh, these are the problems that we have, and these are the gaps that we have. So then now we start to align different projects or different efforts to start closing these gaps. Next slide. So I think that I laid that a little framework, and as I said, we come to the Cyber Pavilion at ITSEC and get a lot more detail. We'll go a lot more information exactly of what that problem set is, and I'm going to bring people that will bring it in detail. It's like electronic warfare, and here's the gaps that we have, or cyber, or even information operations moving forward and understanding that environment. But really, how do we connect that together? And that. So now I'm going to hand over to Dr. Moore so she can present what she has and bringing how we start building that foundational common lexicon moving forward. Catherine, over to you.
Thank you, Colonel Bates. Particularly thank you for that gracious introduction and the excellent stage setting for what I'm about to talk about. I just want to point out this slide deck is on the CISO template. That's the Simulation Interoperability Standards Organization. As Colonel Bates mentioned in his introduction, I do a lot of work in standardization. And so this is an effort that's going on within CISO. So CISO is an open international standards organization. So everything we do is out in the open. And of course, somewhere in here, we're going to come to a URL that says get involved, which is my shameless plug for getting involved in this activity. Next slide, please. So Colonel Bates has done an excellent job of setting the stage for the need for representation of cyber. And, we've done a lot of work over the years in the integration of federated kinetic simulations. And it's become clear that it's now important that we integrate cyber simulation capabilities. A number of organizations have already started building various cyber simulation capabilities at various levels of resolution. So there are cyber ranges out there, which in some sense are a very high resolution cyber simulation. There are also effects-based cyber simulation capabilities. I did some work on a project called COATS many years ago that looked at integrating those into a kinetic simulation training event. But of course, as we're all keenly aware, if we have to go to war, our enemies will not confine themselves to just kinetic. And so we need to be able to represent cyber. I think perhaps later, Alan Geddes may talk about some of the capabilities, cyber simulation capabilities in his portfolio. But I'm just going to talk about the thing that's really in my wheelhouse, which is simulation interoperability. Right? So the idea here is we want to be able to integrate cyber representations into federated simulations, and of particular interest is training simulation environments. So in order to do that, just like we have kinetic simulation data exchange models, we need a cyber one as well. And I think we learned the hard way that it's critical that when we do this, that we get on the same page at the beginning, because otherwise we're building bridges and gateways and patching forever. And so this is an attempt to get us all on the same page about cyber representation early, to save ourselves a lot of money and heartache later. So the idea with the CyberDEM is we want to be able to represent both cyber events and cyber objects in some format that's independent of simulation interoperability solutions. So this is key, right? So we all know about HLA and DIS and TINA, and some of the data exchange models that have been built were built for those specific simulation interoperability solutions. And then so to get those in those multi-architecture environments, which are the reality that we live in, we're winding up, doing a lot of conversion of formats, and sometimes not losslessly or unambiguously between those environments. So what's key here is we want to be independent of simulation interoperability solutions, but it's really important that we can unambiguously translate to those solutions, right? So that's the multi-architecture environment that we need to work in. So with that as a primary requirement, the idea is that the CyberDEM will provide this common representation of these cyberspace conditions so that they can be transmitted bidirectionally between cyber ranges, cyber simulations, and traditional kinetic simulations. Okay, so that's sort of that's our scope. Now, but then there is the problem that, okay, we can't be architecture neutral forever. And so our plan is, once we standardize the CyberDEM in this simulation interoperability solution independent representation, then what we're going to do is we're going to do specific solutions for those well-established simulation architectures. So there will be an HLA Federation object model. The DIS standard will get input from us. So the DIS standard product development group will get input from us. I'll come back to that third bullet in a second. I actually am funded by the Test Resource Management Center, or TRMC, to lead the development of this CyberDEM. So also, by the way, don't get the idea that I'm doing all this. Sometimes people say, oh, this thing that Catherine's doing, and Catherine's really just the chief cat herder. In fact, everybody here on the panel is in some way engaged in achieving this vision. So anyway, so TINA is the test and training enabling architecture. It's specifically focused on connecting to instrumentation ranges, and so instrumented ranges. And so, so we'll do a TINA version of that. And also, by the way, TRMC owns the National Cyber Range Complex, and then we'll do a version in JSON. And then I'll just say, for those of you who are real simulation interoperability wonks, you'll know about the CISO enumeration. So we're going to have input to them as well. Next slide, please. So this is the process we're going through. We've developed a bunch of representative use cases spanning applicable domains. In fact, right before this, I had a meeting with someone who's doing a new one. And from those, we determined the scope of the CyberDEM, such as cyber attacks and effects. And you can see the list. And we drafted a CyberDEM to meet the defined scope. And we represented that in UML. And I'm actually on the next couple of slides going to show that to you. And then as we were doing that, we realized, oh, that's not enough. You have to actually explain to people how to use it. And so there's a guidance document called the CyberDEM Base Objects, Networks, Effects, and Specifications. And then we produced the first drafts of the architecture-specific data exchange models. And by the way, a whole lot of this process is all about, driving to requirements for the CyberDEM. So once we'd done all that and we had a first draft, then we went back and we worked backwards through our use cases. And we said, okay, let's see if we succeeded in meeting the requirements of the use cases. And we mapped the use cases back to the CyberDEM and generated comments, because it turns out, as smart as we think we are, we're not perfect. And so there were, of course, there were things that we missed. So we've generated those comments. We're resolving those comments now. And then we're going to produce a new draft, probably hold another comment round, maybe do a ballot. But we are right now in the process of resolving the comments that we generated through the first several steps on this slide. Next slide, please. So you are not intended to be able to read this in detail. This is just to show you that it does exist. So there are two aspects to the CyberDEM. There's a representation of objects. Those are persistent things in your simulation. If you speak HLA, those are objects in HLA. So this is the current object structure. And then next slide, please. We also have events. And so these are non-persistent things in your simulation. So once again, if you speak HLA, these are interactions. So this was just to show you, yep, there's an actual first draft or 0th draft that we did as part of something called a study group. And this is the thing against which we're working now. And I've decided to spare you from the details of comment resolution. So I'm not going to show you the very detailed comments, but we are working through those right now. So next slide, please. Okay, this is just a quick look at the guidance document, because the CyberDEM itself is insufficient to solve the stated problem. So this is going to give users guidance on how to represent specific objects, attacks, and effects in the CyberDEM. And so it will describe all of the objects and events. There's going to be a section that is on use cases. So I mentioned the use cases. We'll show some use cases in there. And then we'll show the mapping of the CyberDEM to existing interoperability solutions. So these won't be the actual solutions. These sections will talk about things like data types. What are the data types going to be in the various interoperability solutions? So we're working on that in parallel with updating the CyberDEM itself. And there's the shameless plug I promised you. If you want to get involved, that's where you can find us on the CYSO website. Next slide, please. Okay, so I've got a few minutes, I think, a couple minutes for questions, and I see that I've got a couple already submitted earlier. The first one is, as a new hire, what skills should I focus on refining to ensure I'm an asset to my M&S team? So because I worry all about simulation interoperability, I'm going to suggest the following things. The first is that Federation engineering is an engineering discipline just like anything else. It's systems engineering for building federated simulations. And it has a special set of unique challenges, particularly interoperability challenges. And many times in my career, I've seen people start to put simulations together without doing this upfront engineering. And the results are always not what were intended. And these challenges arise over and over again. So I would say Federation engineering and making yourself aware of the kind of interoperability challenges that exist would be critical. So think about the bigger picture and about the fact that federated simulations are a reality now. And then I'll put in another shameless plug for CYSO, because if you want to know about these things, CYSO is definitely the place to go. And then I guess the one other question, someone asked, what new capabilities do you see LDC training requiring in the next few years? And I'm going to take the broadest possible interpretation of capability. So definitely cyber, right? I'd have to say cyber after all of this. But I think that there's a different take on capabilities. So one other perspective could be, well, people are talking about migrating to the cloud, and that has its own set of challenges. And just to be clear, I'm not disagreeing with that as a path forward, but it does have specific technical challenges, and in some cases, process and security challenges. But I think we're going that direction, and understanding that now and facing those challenges now is better than waiting, because they're not going to get better with time. And then I will say, I'm hoping, maybe this is aspirational, I'm hoping for more rapid integration of new capabilities, understanding that this is an age-old problem. We've been struggling for this for the entire time I've been in this business, but I still think it's waiting for solutions. But I do believe that those solutions are probably in the Federation engineering domain, and accepting this as an engineering discipline and working towards better engineering. And so I think that's the end of my comments. Thank you very much.
Thank you very much, Dr. Moore. So, I mean, right there, she just laid out this, I think, really a tip of the iceberg of really finding, if you're going to do engineering, digital engineering, you got to start with the foundational basics and making sure we get those correct. And just so, because, just talk about a joint force, Army speaks differently than the Marines, the Air Force, and the Navy. It's even worse when you start looking at the technical side and making sure that we have that common lexicon, that common definitions of terms moving forward. So not only what Dr. Morse talked about, there's a lot of other things that CISO is working to help us understand that. So now building off that foundation of, how do we have that common lexicon? I want to hand it over to Mr. Alan Geddes and the things that they have been building, because in my opening comments, it's just like, hey, we have this need now. What's being developed now to meet our needs and starting to get off to this complex problem? So, Alan, over to you, please.
Thank you, Colonel Bates. Thank you for that introduction as well. So my name's Alan Geddes, and I'm a Science and Technology Manager at the Army's Simulation and Training Technology Center down in Orlando. Next slide, please. And this slide just talks a little bit about what our organization does. We're under the Combat Capabilities Development Command, or DevCom Soldier Center. And my team specifically is the Cyberspace Warfare for Training Science and Technology Program. And we focus our research efforts on CEMA, or cyberspace electromagnetic activities, and how the Army can replicate those types of environments and operations in its modeling and simulation technologies and capabilities. Next slide, please. And so my team specifically kind of looks at the direction that the Army's going. And one of the ways we kind of determine that is by looking at the Army vision and strategy guides and documents that it puts out, and figure out the types of force structures and the types of operations that the Army seeks to conduct and on what timelines. And one example is, having multi-domain operations capable forces and multi-domain operations ready forces, on the 2028, 2035 timelines. And we also work with operational organizations like Army Cyber Command, or some of the Army's capability developers and all those types of stakeholders, and figure out what the Army needs to be able to do in terms of modeling and simulating cyberspace in support of all of these future concepts like multi-domain operations, or joint all-domain command and control, or information advantage concepts. And then we kind of work backwards. So what can we do today? What capabilities do we have in terms of modeling and simulating cyberspace? And we come up with essentially the gaps that we focus our research and development activities towards addressing. Next slide, please. And so Colonel Bates did a really good job kind of covering the complexities of cyberspace. But essentially, we have different layers to represent, and the layer that you represent in your M&S capabilities kind of determines on the force structures or units that you're trying to train, or what the focus of your exercise is. And as you can see, on the left side, some of the new force structures the Army's standing up in support of multi-domain operations is intelligence, information operations, cyber, electronic warfare, and space. And the representation of cyberspace for each of those different entities is going to be different. But one thing kind of they all have in common is you cannot represent certain aspects of cyberspace until you are accurately or adequately representing the terrain for cyberspace, which is the network, the physical network, the wired and wireless links that communications and all these other layers of cyberspace operate on. And so today I'm going to talk to you about a bit about a research effort that we recently initiated focusing on addressing how the Army represents the tactical network inside of its M&S capabilities. Next slide, please. And so as Colonel Bates covered, we meet, and talk about what the pain points for all of the Army's M&S enabled communities are. And one common theme is, our current capabilities lack sufficient ability to model and simulate network traffic. And it's difficult to incorporate or represent all of these complex multi-domain operations concepts and behaviors if you aren't accurately representing the tactical network in which they operate. And so we recently started a research effort focused on bringing in high fidelity network simulation and emulation and connecting it to existing Army live virtual constructive and gaming M&S capabilities when that level of fidelity and resolution is needed for your training exercises. And to do that, we're going to use another research effort that we are working on down at the SDTC called CYBERBOSS, and that stands for Cyberspace Battlefield Operating System Simulation. And I'll talk a little bit more about that on the next slide. But one of the other goals for this research effort is to lower the barrier of entry to using these types of high fidelity network virtualization technologies when that's needed. Currently, you have to have network engineers and subject matter experts build out the network topologies in your virtualization environment that correspond to your simulation environment. And then there has to be a lot of, interfaces that are developed just for that specific exercise and scenario to be able to exchange information between the two environments. And so we're looking at innovative ways where we can automate some of that configuration and deployment so you don't have to be a network engineer and you don't have to call in specialized subject matter experts who might spend weeks configuring the environments for this exercise ahead of the scenario execution, and then you can only use it for that one exercise. So we're looking at automating some of that configuration and deployment, which we'll again talk about in the next couple slides. Next slide, please. So CYBERBOSS, this is a research effort that we are working on at the STTC, and its purpose is to facilitate interoperability between various disparate external cyberspace systems and simulations that don't natively talk to each other. And so, for example, we have demonstrated how we can take an existing Army constructive simulation that doesn't have very high fidelity cyberspace representations in it natively, and we can connect it to CYBERBOSS. CYBERBOSS provides that the APIs and the common data model to be able to start sending cyberspace object, event, and effect data with that simulation environment. And then we've connected it to high fidelity cyber range environments, and we've shown how we can synchronize activities across both of those different training environments, where kinetic activities inside the constructive simulation can have an impact on devices in the cyber range environment, and vice versa. Non-kinetic operations and activities in the cyber range environment can have an impact on devices inside the simulation. So what we are doing for this research effort is focusing on tactical network modeling and virtualization, and we're going to be leveraging the CYBERVAN capability, which I'll talk about on the next slide in a little bit more detail. But before we move on to that one, just one other topic to mention, that CyberBoss is also going to, provide essentially a cyber cop where white cell, exercise staff can see what's happening across all of these various systems in cyberspace. And some of the other research that we're looking at is ways we can plug in intelligent cyber adversaries into the CyberBoss ecosystem so that you can incorporate those behaviors into your exercise when you don't have cyber range environments or cyber mission forces at your disposal. You'll be able to plug in some of these intelligent cyber adversarial models to be able to still incorporate some of those into your exercise. Next slide, please. And then on the other side of the equation, we're going to be using CYBERVAN, which stands for Cyber Virtual Assured Network. That's a high fidelity network environment that's designed and maintained by Peraton Labs for members of the Army Research Laboratory, or ARL, Cybersecurity Research Alliance, and other research organizations such as us. And so we're working with ARL and their team to be able to connect CyberVan up to CyberBoss. And we recently kicked off this effort, so we're in the early design phase of it, but we're working on adding in the endpoints to be able to send and receive data with CyberBoss to CyberVan. And in the next slide, I'll talk a little bit about some of the use cases that we're going to be working towards for this effort. So next slide, please. So like I mentioned previously, one of our goals for this effort is to be able to automate the network configuration in the high fidelity virtual environment. And the end goal that we're working towards is so that you can design your exercise using the simulation capabilities that you're already using. So you lay down your forces inside your simulation, and then once you initialize and run that scenario, if you have CyberBoss and CyberVan kind of in the loop, the devices and radios in that scenario will get pushed over to CyberBoss, who will then broker those over to CyberVan, who can create a corresponding tactical network that those entities would use to communicate over, complete with the wired and wireless links, all the network infrastructure, the wireless modeling, radio waveforms and everything like that. That will run in the CyberVan environment. And then we're going to use CyberBoss to synchronize those two during runtime, so that if there's a kinetic event inside the constructive simulation that would degrade the network in the real world, CyberVan will be able to react accordingly and take those communication nodes and devices offline, which is going to have an impact on the network topology and traffic flow and ability for entities to communicate, and vice versa. Events or activities that occur in the CyberVan environment are going to have an impact in the simulation environment. And where that's really going to be beneficial and apparent is as we route tactical messaging over the virtualized network, instead of directly between entities inside the simulation environment, which typically operates with perfect comms. When entity A sends a message to entity B, it gets there instantaneously, and is not impacted by kinetic events occurring, that would have an impact on communications in the real world. Instead, we're going to externalize those tactical messages, pass them over the virtualized network, where we can model the latency between the links and model the impacts of jamming and things like that on those communications, and be able to realistically and accurately show the effects that those would have on our ability to communicate, navigate, target, all those types of different things. And it's really going to set the stage or lay the foundational capability for modeling future MDO concepts that we can't until we are accurately modeling the cyberspace terrain, which is the tactical network. And with that, I believe that's my last slide. Next slide. Yep, there's my contact information. So, please feel free to reach out to me with questions or comments or feedback after this. I am going to try and quickly get at a couple questions that were submitted ahead of time. But again, if I did not answer your specific question, please, just feel free to reach out to me afterwards. But one of them that was submitted is, will in-state goals include both joint and multinational participation in MDO M&S training scenarios, or is this precluded by security protocols? And I think the quick answer is that in-states must always include joint and multinational partners, because that's how we fight and that's how we prepare the battlefield prior to any conflict. And even kind of ignoring the complexities of multi-domain operations, it's just inherently difficult. There are challenges associated with making joint and multinational training systems talk to each other, and it's no different when we add in multi-domain operations. But we are working, through that, and we will find a solution. And in fact, there are already examples in the Army where we're getting at that and starting to demonstrate those joint and multinational participation, including, cyber blitz exercises, project convergence, and even standard training events at the Joint Multinational Readiness Center in Germany. So next question real quick, I'll try to keep it kind of quick, is how are AI and ML, so artificial intelligence and machine learning technologies, integrated with M&S for handling complex multi-domain operations? And AI is going to play a huge role in the modeling and simulation. Again, even kind of ignoring the complexities of multi-domain operations, it's going to help us with our distributed M&S environment architectures. We can leverage AI and ML techniques to identify and heal, quicker with our large, more complex distributed events. It's going to help us model more realistic environments and behaviors. And it's going to help us just process data much more rapidly. These exercises, just generate massive amounts of data, and we'll be able to leverage AI and ML technologies to be able to quickly process and parse that and analyze it to help us in our training environments. And with that, I'm going to hand it back over to Colonel Bates.
Hey, thank you very much, Alan. So, just to reiterate what Alan just talked about, so it's as the Army and as in each one of the services builds our capabilities in these different areas, and this is true, we are building these capabilities now and better defining of exactly what we want to. The things that CyberBoss, CYBERVAN that Alan just talked about, and that research effort is helping us better understand exactly where we're at, helping us better define the environment, so we can actually, are the capabilities we are developing, are they accurate, and getting that feedback loop from those subject matter experts talking to those engineers to develop these systems moving forward. So that's something that they're currently working to do now, because how do we build that feedback loop? So now I'm going to hand it over to Clark Heidelball, because now he's going to talk about the framework that we're going to start putting this into to help us better, one, communicate it to the larger environment, but making sure that we are these lessons learned and these capabilities and what we're defining, and we're putting into a, like what Catherine talked about, is some kind of a common lexicon and a way that everybody can understand. So over to you, Clark.
And thanks, Colonel Bates. Appreciate the comments from Dr. Morse and Mr. Geddes earlier. Thanks to NTSA for hosting this and giving us opportunity to talk about this exciting field. There's my contact email address. And so if you've got any questions after this and want to follow up, please jot that down. Next slide. Dr. Morse talked about, building bridges and figuring out how to, and gateways, and how to close the patches of all the tools to work later on. And what we have over the last many decades is an effort across the U.S. Department of Defense to build kinetic warfare models and simulations to understand our system capabilities through modeling, to understand interactions through simulations, to better understand human behavior and human decision making. And the challenge that we faced was not having an approach to this non-kinetic space of cyber electromagnetic activities. when we choose to do things in electronic warfare and we choose to take actions that will have outcomes, what we don't have a clear understanding about is what are the human decisions, and that ripples across many communities, and particularly we're focused here on training, so that's one that we want to talk about for a moment. And so the training community, if we try to interject these effects and conduct these activities, it leaves one to question whether or not it's actually the system that they're on. Is there a problem with the system, or is there actually a CIMA activity that's causing some effect? This slide depicts is another graphic that depicts the complexities of the layers of the domains and whereby we're operating, and cyberspace in our doctrine, and as we understand, is a cross-cutting aspect to this. As Dr. Colonel Bates has pointed out, it is another aspect of human-generated domain. So we want to understand that, and the challenge now is that our operational forces are looking to the future, and they're executing now operations or training to prepare for the future. And there's not a clear understanding of the full range of activities available to them. And so to have a parallel construct for models and simulations is one way for us to put a tool in place for them to understand that as they go forward. And that's really the purpose in creating this framework. It is intended to be a living and breathing effort. Next chart, please. Next slide. We started this, as Colonel Bates had talked about, the process and the working groups and the people working under the Army's Modeling and Simulation Office. Really, conceptually was identified as a problem, a challenge for us back in around 2016. And the community said we'd like to have something that will help us guide our development of tools, data, services that would address cyber electromagnetic activities, the CIMA and non-kinetic aspects. That will also help us to integrate with there's another group that deals with human behavior, and I've seen some questions popping in about human behavior and understanding decision making. So there's a group focused with that. But yes, certainly there is a connection between us, the people that model networking, and that model the information that comes in. This framework project, the first phase, really developed these 4 different areas. And I'll go into a little more detail that where we are now working with Colonel Bates is in sort of what we're calling a second phase, really focused on the Army's creation of these cross-functional team areas, capability developers under the Army's Future Command, focused on multi-domain operations and future technology, future capabilities. The initial effort did not have the opportunity to interface with them because they didn't really exist and they were just starting in 2018, 2019 timeframe. And now as the Army and the Department of Defense's focus has turned towards all domain, joint all domain, the complex operational environment and the Army's multi-domain operations, we now are able to get some insights and start to think about how to frame this problem set for both the developers and probably more importantly is to be able to have conversations with commanders and their staffs about capabilities they want to use in training or in exercises to get ready to create understanding. We'll go to the next slide, please. I'm diving a little bit deeper into that upper right quadrant because when we started out, the question was, well, how do we want to represent what we're talking about? So we went to the doctrine, and of course, the doctrine at that point was relatively new publications. Dating, it's all less than a decade old, but that's what we started out to depict. Using unified modeling language to capture that and then build out this. And so it's really sort of a precursor to now the department's efforts to do digital engineering. And we aligned ourselves with the CISO's CyberDEM effort and not a nod to, again, Dr. Morse's presentation and her effort. And she likes to say it's not hers, and she's herding the cats. And we've been integrated with that because that is an important part, the data exchange and understanding how that will work. And so we've worked to integrate that into into our ontology and understanding. So that was the beginning, and that's really has been the focus of the representation to drive forward. And next slide, please. Right. The major activities under our current effort has been to focus on the different exercises and experiments, the groups of users that are with interest in cyber modeling and simulation efforts. So those that are doing cyber models. We also talk with the assured position navigation and timing people and want to account for what they do. We've heard Mr. Geddes talk about the groups that he's supporting and working with. So we're integrated and been working with us alongside them as we've gone and understanding all of their concerns. We've worked to capture those. We've talked with those cross-functional teams and other groups, principally to help us go from the doctrinal phase, the doctrinal step, into what we termed these mission threads. And those are really tailored use cases that are tied to the way forces may conduct their operations. In particular, with each of those cross-functional teams, thinking about their material development solutions, the investment, and how that doctrine would be applied under their perspective, but with an eye toward what are the cyber and electromagnetic activities that would impact those, and then capture those. And I'll show that in more detail in the next slide. And then the last major effort that we're doing right now is to update all those 4 quadrants I showed you earlier. Again, the heavy effort and bulk of our effort has been on working through the ontologies. With cooperation and working through the Cyber EW working group, we've updated the tools and the tools list and that sort of thing. Next slide, please. This one shows, again, the nod towards digital engineering and in our effort to capture mission threads. We've used activity diagramming to capture those, and that's a walking through, talking through how does a particular aspect, operational force, how will they function? How do they function doctrinally? What are major activities? What systems do they use? What functions do they perform? Capture those in an activity diagramming, and then moving forward into sort of a universal approach, a digital engineering approach. We've applied unified modeling language to capture that. And we're looking at future evolution towards systems, SysML, and that sort of thing. Next slide, please. So we will continue to wrap this up. I'm keeping an eye on the time. I want to be able to get back to Colonel Bates there. So I'll let you look at that for a moment. But we're wrapping up the project through this summer into early fall with Colonel Bates. Particularly trying to put a wrap on most of those mission threads that I've talked about and getting those captured in that ontology, and then we'll update our governance plan and deliver those to Colonel Bates. I think that's my last slide. Again, if you've got any questions, there's my email address, and I'm looking at the time, and I'm open to questions, but I'll yield back to Colonel Bates.
Hey, thanks, Clark. So what Clark just put about and what we just did is now we're putting together these playbooks really that we're getting from the warfighters. It's like, okay, I want to do this effect in this training exercise or this exercise. So how do I do it? And then aligning that with what I want to do with what currently simulations we have on the books. And this is how you integrate it and do it. So it's here's the requirement with the engineering know-how to actually execute that effect in some kind of environment. Looking at time, I want to answer a couple of questions. OSD, Office of Undersecretary of Defense for R&E and their cyber technologies, they're actually doing several technological exchange meetings, and they're starting to really looking over all the services and other government organizations are really looking at modeling and simulation across the services addressing these same kind of topics. So there is over at the Office of Undersecretary of Defense where they're starting to work at integrating it between the services and moving forward on this. And it goes back to some of the questions we have is we have technological limitations that we're doing. When we really want to do a large scale exercise, we have an infrastructure that's actually existing in any of the services, and it's built to a certain network strength. So each installation has a limitation of how much information goes in and out of it. And that's just for the connecting day-to-day operations. And now if you want to replicate a whole new network, that is a limitation that we have to work around, is the information going into and out of an installation and connecting to another one. It's going to be extremely limited. So that's something that we're working through right now within the Army with the cross-functional team on networking of how do we upgrade our overall infrastructure within the United States and some of the outlying organizations that we have. So as again, this is the tip of the iceberg. If you want to learn more about precision navigation and timing and the modeling and simulation things we're doing there, it's going to be at the Cyber Pavilion at ITSEC. Much more detail of what each one of these topics that we're working and each one of these, plus a lot more and other services and what they're doing, it's going to be at that Cyber Pavilion at ITSEC. So if you want to dig into deeper and ask a lot more integrated questions and also understand what's the requirements and challenges that we're having out there, we're going to have those events at the ITSEC this year at the Cyber Pavilion. So I think we're done. I wanted to ask more questions, but we're out of time. So thank you very much for attending today. This is something we're all passionate about, something that we've been working on together for many years. So I mean, this is an easy sell for us to come talk about this because it is a significant need. Not only in the Army, but the whole Department of Defense. So I'm going to hand it back over to Admiral Rob, and thank you very much for allowing us today to speak something that we're passionate about. So thank you, sir.
So thanks, Chad. That was tremendous and hurt my head. So for this fighter pilot, I got to go take an aspirin. But you guys all did wonderfully well, and it really is impressive to see how much detail and sort of engineering approach that is required, especially in cyber, but in all of modeling simulation. Attention to detail is a real big deal, as are the requirements that come from the field. So as we're trying to simulate effects, working back and forth with the customer is really important. We appreciate all of your time, and we know it's precious. The questions we didn't get to, we will try to address. We know who noted them into the system, so we'll try to get back to you with it. But again, I thank you very much for your time and your efforts. It was really a wonderful hour. A couple of items for the wrap up. I just wanted to give you an update on our TSIS a couple of weeks ago. This is our first in-person event for NTSA in almost 18 months, and it was a great success. We had over 800 folks show up in Orlando in person and another 250 on a virtual platform, and by far beat all of the previous TSIS records, attendance records, and you can just sense the relief amongst those who were in person to get back together and talk and have sidebar discussions. And so we see that as a great omen for the future and of all of our events. Leading into that goes to the status of IITSEC in late November. We are fully engaged with the convention center. We are fully expecting a full up IITSEC this year in Orlando. The show floor is growing fast. We have seen some hedging, to find out whether it was going to go or not. And right now we're many months out, and the sales are great. The program is great. All the volunteers are extremely engaged, and the program is really extremely rich. So we'll see you there in October. Lastly, we do have a webinar every month. Our July theme is AR, VR, XR, which is being led by Bob Kleinhappel from SAIC, who's also the chair of our Next Big Thing Committee, a committee that I charged with sort of plotting out the technologies, the capabilities that focus on ITSIC 2025, ITSIC 2030. What does it look like? Where do we find the next big things that are going to be important for our communities? So we see AR, VR, XR, we see cyber, we see a lot of things that are important. And if you have something that you think is worthy of our attention and going into the future, just like synthetic environments and all that, I am all in to help support and build that market around it, but also bring attention to leadership. So thanks for attending. Let us know if you'd like to add topics for the webinar series in the future, or if you'd like to add or sponsor one of our events. So thank you very much, and we'll see you later. Bye-bye.